These light sensing blinds were designed to help you sleep, wake up, or take care of your personal needs, all to help save time and hassle. They can be programmed to operate on a desired schedule for optimal lighting/darkness preferences, or choose the auto adjust so the blind adjusts according to the changes in sunlight levels.
The sensors used in this project are a button, which would give you wireless access to the blinds, allows you to make use of a remote to raise and lower the blinds on command or whenever you want. A rotary encoder, which will track the number of rotations the blinds do to determine if they have been fully raised or lowered, and a photoresistor, which determines the light level and sends data to the cloud so the blinds know whether to open or close.
As you can see in the flow chart, our main argon sends and receives signals to and from both secondary argons. The rotary encoder argon sends rotation data and receives a reset signal from the main argon. The wireless button argon sends the signal to operate the blinds while receiving the blind location signal back.
The main mechanical components in this project used were a rod held in place by two skateboard bearings that is rotated by a motor on one end to lift the blinds. The rod is a 5/16 inch and is set in place by 3D printed assembly and skateboard bearings. The motor is a 12 volt 100 RPM motor with a lift torque of 6.7 kilogram centimeters, which gives a factor of safety of 16 based on a 1 kilogram blind weight. To achieve the 12 volt power from the motor, a DC booster was used to drop amperage and raise voltage.
So the schematic for our setup shows that we have a 5-volt battery source that powers the 3 argons. For the rotary argon, we have a connection between pin A2 on the argon to the encoder, and the encoder is grounded to the argon. We have a connection from A0 and A1 to the encoder.
The second wire out of the battery goes to the main argon, which relays information from the photoresistor to the booster, which then goes to the motor. The wires out of the main argon are the A0 wire, which goes into the positive outlet of the photoresistor, a ground wire, which goes into the negative outlet of the photoresistor, and then pin A1 into the photoresistor, which is the signal. A2 goes into the positive of the booster, which gets 3 volts in and then sends 12 volts out to the motor. The ground also goes into the booster, and then the ground has to relay to the motor, as well as pin A2 relaying back to the motor. The last argon relays information to the button, which allows you to manually put the blinds up or down. And the A0 pin goes into the positive, the ground goes into the negative, and the A1 pin is the signal that is sent back and forth from the argon to the button.
So here's our physical setup of the light sensing blinds. The argon on the left is the encoder argon. The black box in the center is our power bank. The argon on the top is the button, and the argon on the right bottom is the main hub argon.
Here's a close-up picture of the gears, rod, and motor. These help the blinds go up and down, and all the way on the right, that silver box is the motor, and the black squares are the gears across. So here's a video of the blinds opening, and then the next video will be a video of the blinds closing. But as you can see on the motor, it's not spinning perfectly. This is due to an issue with the gears being printed. It still works, but it's just that the side with the motor will open and close a little bit slower than the rest of the blinds.